All right, maybe this will be the last video. I was looking at these last problems. I may not do them all because they're all pretty much the same. I'll explain one or two of them, and then, of course, I'll give you the answers online. 13, find the equation of the line that is tangent to the graph of the given function at this point. So we've done this before. So they're going to give us a function, and then they give us a point, and they say, go find the equation of the tangent line at that point. And the way we do that is we get the slope at that point, and we know one of the points, and we use a point-slope equation, and we're on our way. So the first step, of course, so here is our equation or our function, 2x squared plus 5x minus 10, and the point, this time they give you the x and the y, the point is 2, 8. So the first step is we need to find the derivative at 0.28. So we're going to take the derivative of our function, 4x plus 5, and then I can write it this way. The derivative when x is 2, so that's the point we're talking about, 4 times 2 plus 5. So that's going to be the slope of my tangent line. So I've got my point, I've got my slope of my tangent line. I can use my point-slope equation. Y minus y1, which is 8, equals the slope x minus x1, which is 2. Just do a little bit of algebra and add 8 to both sides. Looks like the equation of the line, the tangent line at the point 28 is y equals 13x minus 18. Now actually B and C are the same thing. You're going to take the derivative, then you're going to plug in your value of x to find the slope at that point, and then you just use the point-slope equation, and you're on your way. So for B and C, I will give you the answers in the key, but I don't think it really helps to do the same thing over again. So I'm going to jump on to 14. 14 asks us to find the second derivative. I actually realize I may not have mentioned this in class, but it's a pretty easy concept, so you could easily look in the book. Here's a function. F of x equals 4x to the 5th minus 3x cubed plus 4. If I take the derivative, we also sometimes call this the first derivative, because now we're introducing the idea of a second derivative. So take the derivative, or the first derivative, 20x to the 4th minus 9x squared. Second derivative, if first derivative is one little tick mark here, second derivative is 2 tick marks, and you just take the derivative now of the first derivative. So that'd be 80x to the 3rd minus 18x. Not very difficult. Maybe let's go ahead and look at B quickly. One over x plus square root of x cubed so first derivative, all right, this is x to the minus 1. Well, we better write this out. There's a lot going on here. Now the derivative. Minus, so minus 1 comes down front, you subtract 1. For this one, the 3/2 comes down front, and you subtract 1. For this one, except now we want to take the second derivative. So minus 2 comes, which times a minus makes it 2. X to the minus 3. 1/2 comes down, that makes it like 3/4 x to the negative 1/2. And this just becomes negative 20. So if we were to make this a little more palatable for the math people, there you go. All right, and finally, at the very end, 2 story problems. Although I keep telling you in class, these story problems aren't that hard because they give you the equation. Let's see if I'm a liar or not. So 15, the growth of a bacterial population is represented by the function, let me just write down, P of t equals 5,000, where, oh, another typo, where P is the amount of bacteria, so P's amount of bacteria, and T is the time in hours. And part A says the amount of bacteria after 5 hours. Well, doesn't that just mean the amount of bacteria after 5 hours? It's like P of 5. $5,000 plus 1,000 times 5 squared. Might have to actually use your calculator just to make sure you don't mess up on the math. Of course, 5 squared is 25. I guess that should be 25,000. Maybe I can do this in my head. Plus 5,000. Looks like after 5 hours, there's 30,000 bacteria. Part B asks for this instantaneous rate of growth. In story problems, instantaneous rate of growth is another word for the derivative. So the derivative of P prime of t, that's a constant. 2 times 1,000 t looks like 2,000 t. And then part C, the growth rate at 5 hours. In other words, what's the derivative at 5 hours? Looks like 10,000. All right, so that wasn't too bad. So now the last problem is another story problem, 16. This says the cost of producing airplanes is given by C of x equals 2,000 x squared plus 2 raised to the 1/3 plus that where C of x is the total cost. So that's the cost in thousands of dollars. and A is the number of airplanes. Find the total cost to produce 20 airplanes and the rate at which the total cost is changing when 20 airplanes have been produced. So the cost to produce 20 airplanes would be just C of 20. So 20 squared plus 2, all raised to the 1/3. So you definitely have a calculator for this. So 20 squared is 400. So it's 402. Raised to the 1/3 power. Times 2,000 plus 700. 15,461. But that's thousands of dollars. If we convert that to actual amount, it's like take that times 1,000. I think it's like over $1 million. Actually, I think I got it wrong. I think it's 15,461,000. Wow, pretty pricey. And then they say the rate at which the total cost is changing when 20 airplanes have been purchased. So now we have to take the derivative. And this is going to be like a chain rule problem. 2,000's out front. 1/3 times derivative stuff inside. So it's like 4,000 over 3 x squared plus 2 squared, the cube root. Oh, there's also an x up here. So, wow, what a calculation. So let me figure out what this, once again, this is 402 squared. And then the cube root. I'll take that times 3 right here. And that all goes in the bottom. Times x, which is 20, times 4,000. And I got in real dollars 489,574. Like per plane. All right, so those are some story problems. Not too hard. Just be careful with your math. All right, so that completes this review.